So we'll do a quick recap on the important point of the last class. Okay, what is that? Let's say if you want to use any class, right? For example, you can see here in the program I have written string. If I write that string in uppercase, okay, that means it is a class. For example, okay, one more class we have been using, that is system.out.println, right? Here, can you see something in the red color here? Yes, red color, leave the color here. If you see anything in uppercase, it means that it's a class. Okay, it is a class. I think we have seen math.py also, right? Math.py or math.power. So many other methods we had seen. This is a variable. So if I'm using all these classes, so how is it executing? Okay, how it is, because all these are the default classes which are present in the lang package. Okay, in the lang package all these classes are present, and whatever classes are present in the lang package, okay, lang package, you don't have to import them. Okay, you don't have to import them if it is present in a lang package. What do I mean to tell is, see, when you go to this my computer, right? When you go to this my computer, there is C drive, D drive, E drive, where you have installed your Java. Most of you will install it in C drive. So if I go to this C drive, okay, if I click this C drive, I'll get this program files and x86, right? Most of the times it will be in program files. Inside the program files there is something called as Java, and when I click that Java, okay, I have two options, JDK and JRE. I'll go to JDK, okay, and in JDK there is a src folder. When you unzip it, I have already unzipped and it is here, okay, src2 I have renamed. So this is what the folders are. Now what is this lang package? That is Java dot, inside Java folder, dot means go inside that folder. There is a lang package. Can you see lang package? Yes, inside that lang package, if I go, let me type yes here, let me type for yes, string. Can you see string here? Yes, you can see string system. Let me write sy, right? System, can you see system here? Yes, which means if you want to call this class, okay, there is maybe one more class called as throwable, there is one more class called as thread, there is one more class called as string buffer, there is a strict math, there is a shutdown, right? These are all the classes. If you want to use them, you don't have to import them. Why? Because they are present in the java.lang package, and whatever is in lang package, you should not import them. You don't have to import them. Then there are some classes which you have to import. For example, scanner class. Is a scanner class, is it present in lang package? No. Then where it is present? It is present in java dot util dot, okay, inside the util package there is a scanner. So if I press yes here, can you see scanner? Yes. So what and all classes are present in other than lang package, you have to import them. So I hope you have understood, what is import and how to import. Okay. Now what I'll be doing today's, right, in today's class, what I'll be teaching you, I'll be teaching you some inbuilt methods of BigInteger class. Okay, inbuilt methods of BigInteger class. Then what I'll be teaching you is, I'll be teaching you sum of first n numbers. I'll be teaching you factorial program. Okay, and I'll teach you what are the limitations of factorial program and how to overcome it. So these are the important things which I'll be doing in today's class. So this today's class is the first step where logical programming will be happening. Okay, so if you already know all these things, then you can directly skip this video. Okay, but what I suggest you is, if you're a beginner, please watch through this video completely. Now let me go here and let me write one thing. Okay, first what we'll be seeing now is how to convert anything to string. That's what we'll be seeing. Okay, how to convert anything to string. Why? Because, okay, if I convert anything to string, using the string I can do any number of operations, because string has many inbuilt methods. Okay, if you want to reverse a number, the logic is convert a number to string, reverse a string, you got your answer. So I hope you are understanding what I'm trying to tell you. Okay, if you want to do any operation, most of the programming questions, even though if it is arrays question, even though if it is numbers question, if you convert it to strings question, it will be much easier for you. So we should be learning how to convert anything to string. Okay, that we have to learn first. So let's see now. Okay, what will happen when you string concat? What is string concatenation, right? Yes, see, your plus operator acts two types, right? If you tell 3 plus 3, it acts as integer addition. But if you write here, if one of the operand is a string, right? Yes, if you write hi plus a, okay, where I have to tell int a is equal to 5. If I tell like this, then what will be the output? Will the output be high a like this? No, right? Output won't be high a, because if you tell a here, okay, a as it is not concatenated to high. The value of a is concatenated. What is the value of a? 5. So high 5 will be the output, string concatenation. Okay. So I have already told you, string plus anything is string. String plus anything is string. So if I compile and execute, high 5 is the answer, right? Yes. Now what I want you to understand is, instead of giving high, what if I tell space here, right? How do I convert an integer 5 to string 5? So this is that question. How do I convert an integer 5 to string 5? So if I compile and execute, watch here. I got string 5, but can you see one extra space here? Yes, that is what I don't need. Okay, I don't need that extra space. Which means I have not converted string integer 5 to string 5. I have converted integer 5 to string space 5. That space I don't need. If you don't need space, you remove the space like this. Sir, can I write empty string within double quotes? Yes, you can write. What is a string? String is anything enclosed within double quotes. So double quotes you are told, between them you have not told any characters, no problem. This is a string also. So when I compile and execute, watch here. I hope you are able to see, right? Yes, there is no spaces here now. So this is the way to convert integer to string. Okay, this is the way to convert integer to string. So if you had a float, the same way, empty string plus anything is string. Empty string plus float you do, it becomes a string. Okay, so this is one of the ways. Then what is the one more way, sir, if you are thinking? See, the one more way is using the inbuilt method. What is the inbuilt method? The inbuilt method is like this. Okay, you are telling, hey, what is the string dot value of is a inbuilt method. Okay, this is a inbuilt method. Watch here. So in this way also you can convert anything to string. Okay, you can convert anything to string. So here, let me, instead of giving a variable, let me write it like this. I can write here empty string plus 5, right? I can write empty string plus 5.67. Okay, I can write empty string plus here I can tell true. I can write empty string plus character C. Okay, yes. So if I compile, okay, I'll cut this. Yes, this is the way, right? Even the boolean value will be converted to string now. Even the boolean value will be converted to string. So it will be like this. All of them are in string format now. Okay, all of them are in string format. The same thing can be applied if you are using this method, value of method. Okay, value of method, string dot value of 5, right? Then string dot value of 5.67, then string dot value of true, right? Let me tell false now. Okay, then string dot value of C, string dot value of C, which is a character. Yes, so what I want you to understand is, what will this value of method will do? String dot value of will convert anything to string. Okay, it will convert anything to string. So I hope you are able to see the output here, right? Yes, please take this screenshot. Okay, take this screenshot. This is the way to convert anything to string. Either use empty string plus something, okay, or you can use string dot value of. So what I'll be typing now is like this. Okay, what is this? String dot value of will convert anything to string. So this is what I want you to understand. Okay, string dot value of will convert anything to string. So this is fine. Now, right, I'll close this. Now what I want to tell you is about what happens when multiple operations are there, right? What happens? Watch here. If I write int a is equals to 1 4 plus 3 plus 6 plus 7. If I write something like this, and if I print system.out.println, print A. So what is actually happening, right? What is the answer? What do you think is the answer? 4 plus 3 is 7, 7 plus 6 is 13, 13 plus 7 is 20. So you will tell 20 is the answer, right? So this is what you thought, right? But what is actually happening there? Okay, what is actually happening there? What is happening is, okay, what you are thinking, same thing is happening in the compiler also. Don't you think 4 plus 3, 7, that 7 has to be stored in the temporary memory of ours? Because that 7, I am adding it with 6, right? 4 plus 3 is 7, that 7 plus 6 will be 13. So I am storing that 13 in my brain. That 13 plus 7 is 20. So I hope you are thinking, right? So here running count, I am definitely doing this running count here. So when I am keeping the running count and adding to the next number, storing that new result and adding to the next number. Agree or not? So same thing here also. If that has to be done, there is a concept called as temporary variable. So whenever you do any operations internally, you don't have to do it. Internally one temporary variable is created. Okay. So what will that do? Whenever you tell plus, right? Whenever you do any operations, so 4 plus 3, 7. That 7 is stored in temporary variable. Okay. That temporary variable plus 6 will be happening. What is temporary variable plus 6? 13. Where is 13 stored? In the temporary variable only. 13 plus 7, 20. Where it is stored? In the temporary variable only. Finally, when it sees semicolon, it understands that yes, operation is done. Whatever is there in temporary variable stored in the left hand side variable, that is A. Okay. So it is like this. Okay. So I hope you understood the theory. Now when I tell you about practical things, so if I write int A is equals to maybe 3 plus 4 plus 6 plus 7. Okay. So what happens here is, since you told plus, internally one integer type temp is created. Internally what will happen? Temp. 3 plus 4, that is stored in the temp here. What is 3 plus 4? This is my temp memory. So temp memory will contain 7, right? What is my A memory? In the A memory, nothing is there because I have not yet given any value to the A. First all this has to evaluate, then the value is given to A. Okay. So 7 is stored in temp. Then what will happen? Then temp is equals to temp plus 6 will happen. Okay. The previous result of temp plus 6. What is previous result of temp? That is 7. What is 7 plus 6? 7 plus 6 is 13. Where am I storing that 13? In the temp. So temp will become what now? 30. Temp will become 30. Okay. Then again it will evaluate like this. Okay. It will evaluate temp is equals to temp plus 7. This is what will happen. What is the temporary memory now? It is 13 plus 7. 13 plus 7 is 20. Where you are storing the 20? In the temp. Your temp will become 20 now, like this. Temp will become 20. Then after that what will happen? There is a semicolon. Now whenever it sees a semicolon, whatever is there in the temp, that is stored, okay, in which variable? In the left hand side variable, that is A. So this is what happens, internally. Okay. So what is there in temp? 20. Now 20 is stored in A. As soon as you store, this temporary variable is deleted because its purpose is over, right? It's deleted. That is why your A value will be 20. So I hope you understood what internally happens, right? Yes, so temporary variable is created. Okay, fine. Now what I'll do is I'll be writing one. I will erase this first. Okay. New slide. Okay. So the thing is, now we have to find sum of first n numbers. Okay, sum of first n numbers means I have to do 1 plus 2 plus 3 plus 4 plus, like this, I have to do 1 plus 2 plus 3 plus 4, right? This is sum of first 4 numbers. What is 1 plus 2 plus 3 plus 4, right? 1 plus 2 is what? 3. 3 plus 3 is, 1 plus 2 is 3. 3 plus 3, what is the answer? 6. 6 plus 4, what's the answer? 10. So I hope you are noticing here, what you are doing is, you are adding two numbers. Whatever is its result, we are storing it to one variable, right? Then adding to the next number. Whatever is the result, you are storing it in a variable and adding to the next number, and so on. Okay. So if I have to do this, 1 plus 2 plus 3 plus 4, yes, understand this thing. whenever you are seeing this logic, is something plus something plus something plus something is occurring, whenever you see the logic where something plus something plus something plus something is happening, then its meaning is only one thing. What you have to do is, the logic will be like this. Okay, you have to tell, hey, something, that is sum is equals to sum plus something is happening here. Okay, what you're doing is, the previous value of sum should be added to something, right? So this previous value of sum should be added to something, and that something should be stored in sum again. Okay, I want you to understand that. Don't worry, this is a beginner's class. I know when I trace it, you'll understand more clearly. Okay, so whenever in the programming class you see addition is happening, right? Something plus something plus something plus something. If this is happening, then what you have to think? Sum is equal to sum plus something. Okay, so what you are adding here, that we'll see now. Can you see that 1, 2, 3, 4 increment is happening here, which means I can use a loop now. So let me write a for loop where I'll tell int I should start from which number? Yes, it is clearly visible. I should be starting from number 1. I should be less than or equals to, should go to the number 4. So as of now, let me write the number 4, I plus plus. So don't you think, what is that something here? You have to add something plus something, right? What is that something? That is nothing but the I value only. That I is only our something. Okay, so if I write like this, then after the for loop, if I tell system.out.print, okay, print what value? Print the sum value, right? Print the sum value. Yes. Yes, so in this case, we will be getting the output. So initially, what should be my sum value? Because variable I have to declare, right? So I have to tell int sum is equals to, it has to be empty in the beginning. It has to be empty in the beginning, right? It has to be empty in the beginning. So if you want me to give a live example, just wait a minute. I'll be giving a live example. So let's imagine that this is our sum, right? What is this sum? This sum is a variable which will store the intermediate result, right? When I want to do 1 plus 2 plus 3 plus 4, each and every time the intermediate result, the temporary variable, remember that logic, temporary variable, where it will store the intermediate result, and that sum, that will be our sum, and this is our sum initially. Okay, so if I want to collect something and if I want to add them, don't think my collecting variable should be empty in the beginning, right? It should be empty. See, it should be empty, because imagine that these are the numbers, right? I'll be getting 1, 2 and 3 and 4, right? So these are the numbers which I'll be getting, right? These are the numbers which I'll be getting. From whom? From the for loop. I'll be getting it from whom? From the for loop. Now the question is, will the for loop give me all the 4 numbers at once? Will it tell, take these 4 numbers? No, right? It will not do like that. If it had done, maybe that was easy for us. But what this for loop will do, it will give you a number 1 by 1. So when it is giving us a number 1 by 1, so how to calculate? That's what I'm going to explain you now. Okay, so let me take this. Yes. So which number can you see in the beginning? You can see 1. Yes, for loop is ready to give this 1. Yes, for loop is ready. Now what should I do here? I have to keep my bucket, I have to keep this bucket empty. This is my sum variable. I have to keep it empty. Now for loop, right? I am the for loop, right? I am giving this for loop what value? 1 value. Now what I want you to understand is, don't you think one temporary variable is created internally? Because when you tell sum plus something, temporary variable is created. Now when you are telling plus, when you tell plus, what will happen? The sum value is given to the, imagine that this is our temporary variable. Okay, this is our sum variable, this is our temporary variable. Okay, so sum content, whatever is in the sum, I have to give to the temporary variable. I have given to the temporary variable. Plus I value. Now what is the I value which is giving for me? I am getting the I value as 1. 1 is given to the temporary variable. So sum value is given to temporary variable. The value 1 is given to temporary variable. Now what should happen? Now there is a semicolon. Now whatever is in the temporary variable, I have to tell, store it in the sum again. Can you see store it in the left hand side variable? Yes. Here left hand side variable is what? It is sum. So I am storing it in sum. Okay. I am storing it in sum here. Yeah, I am very sorry, Okay, I am storing it in sum. Okay, it's not going on. Okay, I am storing it in sum. Then after that, what will happen? After that your I will increment. Now your second I value is ready. Second I value is ready. What's the second I value? 2. So first what will happen? Sum plus I. Sum plus means temporary variable is created. First you are telling give the sum value to the temporary variable. Yes, the sum value is given to temporary variable. After giving the sum value to the temporary variable, then you are telling give the I value to the temporary variable. As you can see now in my temporary variable, don't you think 1 plus 2 is there? Yes. So sum value, the previous sum value plus the new I value, you are adding them. After adding, where you are storing? You are storing it in the temp. So I am adding these two and I am storing it in the I am storing it in the sum left hand side variable. So my bucket, my sum will contain 1 plus 2 now. My bucket will contain 1 plus 2. Then your I will increment. Can you see the third variable is ready? Third number is ready? Yes. You are telling sum is equal to sum plus I. So sum content is given to the memory. So sum content I have poured it, it is in the memory like this. Okay. So if I, okay. So sum content I have given to the memory. Now after adding some content to the memory plus I value, give the I content to the temporary variable. So I have stored I content also, right? Then after sum plus I, there is a semicolon. Whatever is in the temporary variable stored in the left hand side variable. What is the left hand side variable? Sum. 1 plus 2 plus 3 are stored in the sum like this. They are stored in the sum. Then your I will increment. Your I will become 4 now, right? I will become 4. So what you telling? Are you adding the I value to the temporary variable first? No. Sum is there, right? That's why the sum content is given to the temporary variable. Sum content is given to the temporary variable. After that, then the I content is given to temporary variable. Addition is done. What is in the temporary variable? In the temporary variable now 1 plus 2 plus 3 plus 4. Semicolon, whatever is in the temporary variable, that should be given to the left hand side variable sum. After that, I will increment. There is no more paper now. For loop will end. And finally, what you are printing? You are printing whatever is there in the sum. What is there in the sum? 1 plus 2 plus 3 plus 4. 1 plus 2 plus 3 plus 4 is there in the sum. I hope it is clear. See, don't you think if this has to happen, if you want to add only 1 plus 2 plus 3 plus 4, initially, don't you think this has to be empty? My sum has to be empty, should be 0, because imagine that if my sum was not 0, right? If there was something which was maybe a different content, if my sum variable, if it had 1 or 2 or 100, what would have happened is you would have added 1, 2, 3, 4, okay, to that pre-value, right? Whatever value was there, for that value you would have added 1 plus 2 plus 3 plus 4. You don't want to add 1 plus 2 plus 3 plus 4 for any other value. You want to add 1 plus 2 plus 3 plus 4 for a empty sum value. Because you want only 1 plus 2 plus 3 plus 4. In that case, it has to be empty. Right? Yes. So I hope it is very clear. Right? Okay. Now let me trace let me trace and help you what is actually happening here. Okay. So if I write down the memory diagram for this. So first I have to create a memory diagram for sum. Yes. My sum is initially 0. Yes, let it be 0. What is my I value? I value is 1. Okay. That's it. There are only two variables here, sum and I. So when I trace it, okay, I value, yes, sum value became 0. Yes. I value becomes 1. I value becomes 1. Yes. Is 1 less than or equals to 4? Yes, 1 is less than or equals to 4. Condition is true. If the condition is true, you are telling execute this statement, right? Sum value. What's the sum value now? Sum value in the memory is 0 plus I value in the memory is 1. What is 0 plus 1? 1. 0 plus 1 is 1. Where are you storing? Sum. So in the sum, what are you storing? Don't tell 1. Let's say in the sum, we are storing 0 plus 1 only. 0 plus 1, where are you storing? In the sum. I hope this is clear. Okay. After this, what will happen? What will happen is I will increment to 2. I will increment to 2. It will check the condition. A is 2 less than or equals to 4? Yes. Okay. Plus, what's the I value here? I value is 2 in the memory. I hope you can see, right? I value is 2. But what's the sum value? You see the sum value, it is 0 plus 1. We know that 0 plus 1 is 1, but let's write 0 plus 1 so that you'll understand, how this tracing is happening. So what is 0 plus 1 plus 2? 0 plus 1 plus 2 is 0 plus 1 plus 2 only. Let's keep it like that. Where am I storing? In the sum. So my sum, don't think it will become 0 plus 1 plus 2 now? Yes. So I will erase this now. Then I plus plus, because control comes here, right? I plus plus, I becomes what now? 3. You will check the condition. A is 3 less than or equals to 4. Right? Yes, condition is true. So I value, right? What's the I value? I value right now is 3. So 3 is there here. You're telling plus some value. What's the sum value here? Sum value is 0 plus 1 plus 2. Now what's the addition? 0 plus 1 plus 2 plus 3 is 0 plus 1 plus 2 plus 3 only. You keep it as it is as a beginner so that you'll understand how this is happening. Now where are you storing that 0 plus 1 plus 2 plus 3? You're storing it in the sum. So my sum will be a new value now, which is 0 plus 1 plus 2 plus 3. Then I plus plus will happen, I becomes 4. It will check the condition is 4 less than or equals to 4. Yes. Okay. Then what will happen? I value. What's the I value right now? I value is 4. You write the 4. Plus sum value. What's the sum value? It is 0 plus 1 plus 2 plus 3. So what is 0 plus 1 plus 2 plus 3 plus 4? It is 0 plus 1 plus 2 plus 3 plus 4. Where are you storing? In the sum. So my sum will contain 0 plus 1 plus 2 plus 3 plus 4 here. Right? Then I plus plus will happen, I becomes 5. It will check the condition, is 5 less than or equals to 4? No, condition false. When the control comes out, you are printing the sum, and what is there in the sum? Now don't tell 0 plus 1 plus 2 plus 3 plus 4. When you are printing the sum, the addition will happen, right? That is 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10. So 10 is the output. What I want you to understand is, imagine that sum was not 0. Because this sum is 0 here, you are adding is 0 here. By default there is a 0. If your sum was 1 or 2, don't you think for this result 2 would have been added? So sum of first 4 numbers wouldn't have been 10. The sum of first 4 numbers would have been 12 if the starting value was 2. Okay. So it should be 0 only, because in addition, right? In addition, anything plus 0 is the same thing only, right? So plus 0, I have to initialize this 0 so that the first value which I am getting, I am not changing anything here. Okay, so I want you to understand what's the importance of 0 here. So I want you to take this screenshot. Okay, take this screenshot. So I hope you have taken the screenshot. Now I hope you have understood also how simple it is. So always remember. Okay, so int n is equals to 4. Let me write now a variable int n equal to 4. I'll be writing a for loop here where int I should start from 1. I should be less than or equals to given n value I plus plus. I have to create one variable sum. For addition, my sum has to be 0. Okay, for addition, my sum has to be 0. So I'll tell int sum is equals to 0. Simple. Okay, now let me write here. Okay, like this. Okay, whenever I have to think, right, that is some addition is happening, something plus something plus something, always one thing should come to your mind. Sum is equals to sum plus something. That is what you have to understand. See, I am telling you so that you will not get confused in the future classes. Okay, in the future classes, I'll tell when you are doing Armstrong program or many other programs like that, strong number, Armstrong number, we will be using this logic. Okay, so sum is equal to sum plus something. What is that something? That is 1, 2, 3, 4. How to get that 1, 2, 3, 4? That is the I value. So sum is equal to sum plus I is the logic. Okay, yes. Let me write here like this, and here I will tell that is system.out.println. Okay, println. What you want to print? Print the sum value. Let's see. See, answer is 10, right? We got the answer as 10. Imagine my sum value was not 0, right? It was 2. So what will happen is, instead of happening 0 plus 1 plus 2 plus 3 plus 4, now 2 plus 1 plus 2 plus 3 plus 4 means, which means 2 will be the extra value. Instead of 10, I'll be getting 12. See, like this, which I don't want. I want a pure first n terms. So sum has to be 0. Okay, I'll tell you one very important thing. That is, this is actually an important number pattern here. Okay, sum of first n numbers, right? If my n value is 1, what is sum of first 1 numbers? That is, sum of first 1 number is what? Sum of first 1 number is 1. Sum of first 2 numbers, 1 plus 2. What is 1 plus 2? 3, right? So it will be 3 here. Sum of first 3 numbers, 1 plus 2 plus 3. That will be 6. So this number series is very important. Okay, this number series is very important. So 6. So you have to understand, right? This number series 1, 3, 6, 10, 15. Okay, this number series is very important in programming. Okay, you have no idea how important it is. You have to remember, like whenever you see this number, right, whenever you see this number 1 3 6 10 15, immediately you have to understand sum of first n number logic. That's what you have to understand. Okay, now let's see here. Okay, what else can we do here? Okay, sum of first n numbers. Now the thing is, this whole program I don't have to write here. Imagine my n value is maybe 100. Don't you think now sum of first 100 numbers is happening here? Sum of first 100 numbers, right? So if I compile and execute, watch here. Okay, I am executing. Okay, so 5050. You tell me how many times my for loop has executed, right? How many times my for loop has executed? Okay, don't you think when my n value is 100, my for loop will execute for 100 times? If my n value is 1000, my for loop will execute for 1000 times. If my n value is 1 crore, my for loop will execute for 1 crore times, right? It is not efficient. There is one code, our beautiful mathematicians have developed one direct formula for this. If you want to find the sum of first n numbers, don't write a program for with including a for loop and all. It will take a lot of time. There is a direct formula. Okay, what's the direct formula? The direct formula is something like this. Okay, watch here. I hope all of you might be knowing this. Okay, maybe. So n into n plus 1 divided by 2. This is the code. This is the logic here. For example, n value was 4, right? For us, n value was 4. Yes. For that, what was our sum? The sum was 10. Let's see here. If n value is 4, the code will be, formula will be 4 into 4 plus 1 divided by 2. That will be 4 into, what is 4 plus 1? 5 divided by 2. What is 4 into 5? 20 by 2. That is nothing but 10. So I hope you got your answer. Okay. So you tell me, if your n value is 100, will this code run 100 times or only one times? Only one times. If your n value is 1000, you can notice that this will execute only one times, right? Yes. So we have improved our efficiency of the code. I hope this is clear, right? For example, if n value is 3, right? If n value is 3, okay, 1 plus 2 plus 3. Don't you think the sum will be 6, right? Our sum value is 6. Let's see here. Okay, if n value is 3, that is 3 into n plus 1, 3 plus 1 divided by 2. 3 into 3 plus 1 is 4 by 2. 3 into 4 is 12 by 2, that is 6. I hope it is very clear that we have to use this logic here. Okay, we have to use this logic. N into n plus 1 by 2. Okay, fine. Now, why I am telling so much, maybe I'll give one question here. When I was seeing this movie, right, Super 30, Hrithik Roshan's movie, right, Super 30. So there one question was asked, right? What is the question? The question was, okay, see, I'm not doing something about programming now. I'm telling you how to think logically. Okay, how to think logically, I'm teaching you that. Here there is no programming actually. There is a question which was asked for the students by the Hrithik Roshan. If there are two people, right, this is the person A, this is the person B. If there are two people, how many unique handshakes will happen? So A and B will handshake. So how many handshake has happened? Only one, right? So only one handshake, because if I give him handshake and he can't give me back again, because that we have already handshaked each other, right? So only one handshake will happen. So he's asking, if in the room if there are 30 people, how many unique handshakes will happen? So this is the question which was asked. And if you directly simply look at it, it is very difficult, right? But actually it is easy if you just analyze. Okay, and this is what you have to do in programming also. In programming, you have to take different test cases. Hey, what will happen if there are two people? What will happen if there are three people? What pattern it follows? This thing you have to build. Okay, so I'll help you now. Watch here. So I've got to know if there are two. I'll make a table here, right? I'll make a table because that is very important. Table, doing the table, keeping the record of test cases is very important. The table I'll tell how many number of people, right? Number of people. Okay. And here it is handshakes. It is handshakes. So number of people when there are two people, right? When there are two people, okay. So how many handshake has happened? One handshake has happened. So if I tell if there is only one person, number of people is 1. How many handshake will happen? 0. If there is only one person, can I do a handshake with anyone? No. So answer is 0. If there are two people, how many handshake are you seeing here? one handshake you're seeing. Let's see what if there are three people, right? If there is A, B and C, how many unique handshakes will happen? Let's say A will give handshake to C, 1. C will give handshakes to B, 2. A will give handshakes to B, 3. Can B give to C again? No, because that link is already there. Can B give to A again? No, that link is already there. So how many arrows you are seeing? How many lines you are seeing? 3 lines. So if there are 3 people, okay, there are 3 handshakes. Okay, done. Sir, what if there are 4 people, Let's take that 4 people example. A, B, C, D. I'll be writing something like this. A will give handshakes to B, 1. A will give handshake to C, 2. C will give handshake to D, 3 and 4. C will give handshake to B, right? And A will give handshake to D. Now you tell me, is there any other pair which is left out? Did this B, did it give handshake to A? Yes, link is there. Did B give to D? Yes, that link is there. Did give this B, did it give to C? Yes, that link is also there. Did C give handshake to all the other 3? Yes. Right? Did D give this handshake to all the other 3? Yes. So if I start to count how many total handshakes, it is 1, 2, 3, 4, 5 and 6. So when there are 4 people, there are 6 handshakes. Right? Now let's see when there are 5 people, what is actually happening here, right? So A, B, C, D and E. So let's see how many handshakes will happen here. Okay. So see, this is the way where you have to do programming also. Okay. You have to just keep on record of test cases here. What will happen when the n value is 1? What's the output? And after looking at the table, you have to now create a formula. Okay. Now let's see. Did A give handshake to B? Yes. Did A give handshake to C? Yes. Is A giving handshake to D? Yes. Is A giving handshake to E? Yes. This is done. So from A, all the handshakes are done. Now let me come to B. Did B give handshake to A? Yes, it is already done. But did this B give handshake to C? No, I'll be writing that. Okay. Did B give handshake to D? No, I'll be writing that. Did B give handshake to E? No, so I'm including that. So from the B, all the handshakes are finished. Now let me come to C. From the C, did I give handshake to B? Yes, link is already there, right? From C, did I give handshake to A? Yes, it is already there. From C, did I give handshake to D? No, I'll include that. From C, did I give a handshake to E? No, I'll include that like this. So from C, I have given handshake to all the things. So let's see from D. From D, did I give handshake to C? Yes. From D, did I give handshake to B? Yes, it's already there. From D, did I give handshake to A? Yes, it's already there. From D, did I give handshake to E? No, I'll include that like this. From E, did I give handshake to A? Yes. B? Yes. C? Yes. D? Yes. So I wanted to count, how many lines are there, how many handshakes are there. So if I count 1, 2, okay, 3, 4, 5. Outer lines are 5. Inner lines 6, 7, 8, 9 and 10. So I want you to understand, right? When there are 5 people, how many handshakes? 10 handshakes are there. 10 handshakes are there. Now, what I told you, whenever you see this series, right? Can you see this series? I have just taught you, right? That is sum of first n numbers. Sum of first n number series. This is okay. Sum of first n number series. I hope this is clear, right? So if someone asks, right, if there are 6 people, how many handshakes? Definitely it is 15. It is 15 handshakes, 100% for sure, because your data is telling you. Now we have to make a relation, right? So number of people, okay, number of people, int number of people, NOOP, right? I will write NOOP, means number of people, that is 5. Okay, let me tell, number of people is 4, right? If number of people is 4, okay, if number of people is 4, can you tell me, can I do 4 into 4 plus 1 by 2? What is 4 into 4 plus 1? 4 into 5 by 2, that is 10, right? But can you see here, when the number of people is 4, is the value 10 or is the value 6? The value is 6, which means a small calculation you want to do, that is, okay, number of people is 4. If the number of people is 4, my int n value, right? Int n value is number of people minus 1. Okay, NOOP minus 1 I have to tell. This is my n value. for this n value, I have to tell n into n plus 1 divided by 2. Yes, for this new n value, you have to create a formula. For this new n value, because you can see in the diagram that when the number of people is 1, okay, what is sum of first one number? Sum of first number is 1, right? But you are seeing output as 0, which means this 1 has to be subtracted by 1, then has to calculate n into n plus 1 by 2. When your number of people is 2, first you reduce that number of people to by 1, right? 2 has to become 1, and for that 1 you have to do 1 into 1 plus 1 by 2. Okay, so what I am telling you is, when the n value, when the number of people is 5, you have to decrease that number of people first. Okay, you have to decrease that number of people, because that is how it is. 5 has to become 4. On that 4 we have to find the formula. So I hope this is clear, right? Yes, you can see here, this is what we have to do. I have to create a new n value where I have to decrement the value by 1, right? Yes. So here, if I write it down, NOOP, let's imagine NOOP is 5, right? Imagine NOOP is 5. If NOOP is 5, what is my n value? That will be 4. What is 4 into 4 plus 1 by 2? That is 10. So when my number of people is 5, my handshakes will be 10 here. So if I write a program for that, you can watch here. Yes, before writing that program, right, you can write it like this. You can write this, okay? What you have to write? You have to write sum is equals to, okay, sum is equal to directly n into n plus 1, okay, divided by 2. N into n plus 1 divided by 2. Okay, let's see. Okay, for the n value 100, okay, 5050. So should I give one more bracket here like this? You don't have to give one more bracket. Why? Because multiplication and division have the same precedence, which means from left to right it will happen. First it will multiply these two things, because left to right associativity, then it will divide by 2. So this is the way, right? When my n value is 4, okay, the output will be like this, right? So, and yes, my sum is 10. As you can see, I am not writing any for loop, because whatever the n value is, your code will execute very fast. Please take this screenshot. Sum of first n numbers. Yes. So now let's see. Let's ask the user, right? How many people are there in the room, so that I want to calculate how many handshakes is possible. So if I want to take input from the user, don't you think I have to use scanner here? Yes, scan is equals to new scanner, and here I have to write keyboard. Okay, from where you have to scan? Do you want to scan from the file? No, from the keyboard, and keyboard is a standard input, and standard input for us, the Java creators have given one object for us, standard input. So that is system, okay, system dot in. Okay, yes, this is the input, keyboard is the input. Yes. After that, let's say, right, how many people I want to ask the user, number of people, okay, people, I want to ask him number of people, how many number of people. So before taking the input, I have to print something in the screen, system.out.println. I have to print something. What do you want to print? I have to ask a user, how many are in the room? How many are in the room? That is what I'll ask. Okay. He will read this message. After reading the message, he will enter something. And whatever he has entered is a number. So how do you take a number? You have to tell, next int is a method. But next int is a method. To call a method, you have to use an object. You have already created an object. Scan.nextInt. You have to tell. So you have taken the number of people. 5 people are there. You have taken. As soon as you have taken 5 people are there, you have to tell, hey, my int n value which is required for the formula is nothing but number of people, okay, number of people minus 1. This is what I have to tell, because according to the formula, that is what I have to do. Number of people minus 1. As soon as I get my n value, I'll be telling, int sum is equals to, or let's say handshakes, right? I'll tell hs, int hs means handshake. So I'll print something to the user now. Okay, total handshakes, right? Total handshakes are I want to attach a value of the hs, so I'll tell plus HS. If you tell plus, you are adding a variable when you are printing. So this is what we'll be doing. But when I compile, what will happen? Watch here, right? So when I compile, okay, what it might tell, okay, it will tell cannot find symbol, right? For what? It cannot find symbol for the scanner class, because scanner, okay, scanner is a class which is not present in the lang package, so I have to import it. So import Java, right? Java dot util dot where it is present. It is present in Java dot util dot scanner, right? Scanner is present here. I have to import it like this. So when I compile and execute, watch here. Yes. User, you know how many people are in the room? I'll tell 5 people are there in the room. When I tell 5 people there in the room, what this will do? It will take that 5 and store it in number of people. Then what will happen? The number of people minus 1 is stored in n value. Then that n value is sum of first n numbers we are doing, and the total handshakes are 10. And for 5 people, if you notice, you know, total handshakes are 10. See, for 5 people, total handshakes are 10. Right? So why you are doing that int n is equals to number of people minus 1? Why I am doing like that? Why? Because see, it's very simple. Because if there are 5 people, so if there are 5 people, if see, I'll tell n value is 5. If there are 5 people, should I use a formula as n into n plus 1 by 2? Should I do it directly like this? Why? Because it is 5 into 5 plus 1 by 2. 5 into 5 plus 1 is 6 by 2. 5 into 6 is 30. 30 by 2 is 15. But tell me, when there are 5 people, is there 15 handshake? Watch here. When there are 5 people, okay, is it 15 handshake or 10 handshake? There are 10 handshakes. So to understand what a number of people is there, directly for that I should not apply n into n plus 1 by 2. I should not do that. I have to decrement the value by 1. I have to make that 5 as 4. Okay. Now don't think 10 is nothing but sum of first 4 numbers. Yes. So definitely 5 has to become 4. That is the reason, you know, I have decremented that entered value minus 1. I have decremented by 1 so that I can use it in the program here. Okay. So I want you to take this screenshot. Okay. I want you to take this screenshot here, maybe with the output also, right? So that you will have full clarity here. So how many people are in the room? 5 people are there. So total handshakes are 10. Please take this screenshot. Take this screenshot. So this was actually an aptitude question, right? But this is how you have to think. What you have to always do is make a table of this n value, what will be the output. Then you analyze the number series. Is it multiplying by 2 or is it following a number series? All these things you have to think. Okay. I'll close this. I hope, I don't know whether you have taken the screenshot of this diagram. If you are not, you can take it now. Okay, take this screenshot also. Okay. So I hope you have taken the screenshot, right? Now what I'll do is I'll undo here, because what I want now is this the same program which was there previously. So let's see, when my n value is 4, am I getting the output as 10? So am I getting the output as 10? Yes, I'm getting the output as 10. So what is happening here? Since I told sum is equal to sum plus I, don't think 1 plus 2 plus 3 plus 4 is happening, right? For example, if I go to the diagram here, okay, can you see here 1 plus 2 plus 3 plus 4? Can you see 1 plus 2 plus 3 plus 4? Yes. The question is, what if I wanted, right, instead of 1 plus 2 plus 3 plus 4, what if I wanted 1 into 2 into 3 into 4, right? Instead of plus here, what if I wanted multiplication? Don't you think what I should have done is, instead of telling sum is equal to sum plus I should have told sum is equal to sum into I. Simple. Whenever you see whenever you see something plus something plus something, sum is equal to sum plus something is the logic. Whenever you see, you know, sum is equal something into something into something, then what is the logic here? That is sum is equal to sum into something. So I hope it is very clear for you to notice here that whenever there is a plus, right, sum is equal to sum plus I. Now you are seeing multiplication, multiplication, multiplication. So now it is sum is equal to sum into I have to tell. That's it. Sum is equal to sum into I. Let's see. I will go here and I will tell, you know, sum is equal to sum into I. So what will be the output here, right? If I do 1 into 2 into 3 into 4, what will be the output? 1 into 2 is 2. 2 into 3 is 6. 6 into 4 is 24. So will I get 24 as the answer? You have to think now. Will I get or not? Will I get? So you have to think. Let's see. What are you thinking? Will I get 24 or will I get 0? Right? Will I get 0? So can you see I'm getting 0? Why? Why? Because yes, most of you already know. Can you see here? Here into 0 is happening here. Yes, your I values are incrementing. I agree. 1 into 2 into 3 into 4 is actually happening. But what was the initialized value for the sum? Don't you think sum was initialized with 0? And if you initialize with 0, 0 into anything is also 0. 0 into anything is 0. Yes, that's a problem. Now, how do I change this initialization value so that if I do 1 into 2 into 3 into 4, I will get the original value 1 into 2 into 3 into 4. Now, don't you think this 0 has to change it to 1 here? This 0 has to change to what? It has changed to 1. So that 1 into 2 into 3 into 4 into the previous value 1 will be no difference at all. So that is very important here. My sum value has to be 1. So I'll go to the code here. I'll tell int sum value has to be 1, and this is called as a factorial of a number. What is a factorial of a number? Factorial means, okay, if someone asks factorial of a 5 into 4 into 3 into 2 into 1 you have to do. So initially what should be my sum value? My sum value has to be 1. So if I compile and execute, right, watch here. So 24, right? Yes, because 4 factorial is 24. If I make n value as 5, I hope it is very clear for you. 5 factorial is 120. Okay, 5 factorial is 120 because 5 into 4 into 3 into 2 into 1 is 120. So we have got the output here. So what changes we have to do? Sum is equal to sum plus I should have changed to sum is equal to sum into I, because now multiplication I have to do. Not only that, initially my sum was 0 because that is for addition. Now since I am doing multiplication, it has to be 1. Okay. Now the thing is, since I am doing multiplication, since I am finding a factorial of a number, it is not good to keep the variable name as sum, because I am not doing sum now. So it is irrelevant. The name is irrelevant now. So let me change the variable to what? Let me change the variable to fact. Why? Because I am finding a factorial of a number. So let me change it to fact here like this. Wherever there is sum, I will change it to fact. And I am printing not sum, I am trying to print fact here. Like this. Okay. So I hope this is clear. It is very simple. Now what am I doing? Instead of 1 plus 2 plus 3 plus 4, I am doing 1 into 2 into 3 into 4. So 5 factorial will be 120. Okay, I want you to take this screenshot here. Okay, factorial of a number. Please take this screenshot. So I hope you have taken this screenshot here. Okay, now I want to show you one thing. The thing is, factorial program is very easy, right? Very easy. That is why they will not give the value 5. They will give the value 500. Something like this. 500 they will give. What is 500 factorial? Definitely it's a very big number, but that big number can you store in integer, because integer has a limit. Okay, integer has a limit, double has a limit. Okay, so since there is a limit, you are not able to find 500 factorial. Imagine that you are a scientist now, right? You are a scientist. If you are a scientist, sometimes maybe you want to find 1 crore factorial. How to find that, right? How do you find 1 crore factorial? Definitely that is not stored in the integer base here. It can't be stored in integer format. Then how do you store that big integer, right? Yes, so I hope you are already able to guess, right, what you have to do. So there is a problem here. So what's the problem here? The problem is it will cross a range. Now you are thinking, hey, I will store in long because long is greater than integer. Long is greater than integer. You try, okay? You try. Tell me one thing. If you change it to long, right? If you change it to long, still getting 0. Now you are thinking, what are you thinking? Sir, don't change that n value to long. Okay, you have to change the fact value to long. Okay, you have to change this to long. Why you have to change? Which variable you have to change? How do you think that? See, you tell me you are multiplying something, and where are you storing the result? You are multiplying I value and you are storing the result in fact, which means fact is a variable. Fact is a variable which is supposed to contain many data. It is supposed to contain huge data. So fact should be long type, not n. N is not long type. I want you to understand that. Is it clear? The variable which will hold the result should be the long type, right? So which is the variable which holds the result each and every time? Fact is a variable. That is why I have made my fact as long type, right? So if I compile and execute, watch here. So fact is a variable which should be long type. So even if I make it as long type, it is not able to store the 500 factorial. Then what to do, right? Yes. So still, what you want to do? You want this fact data type to change. You want the fact data type to change. So it should be what type now? It should be big integer type, because you are storing a big integer in a variable fact. So you write here, a big integer. You write a big integer fact equals to 1. This is what you have to tell. Okay, this is how to initialize 1 to big integer. I want you to understand this is how to initialize 1 to big integer. Okay, let's see. If I compile, what will happen? Definitely compile time error. Why? Because it doesn't know what is big integer. You have to tell import big integer. Where is this big integer present, right? Big integer is present in, watch here, big integer is present in, I'll show you where it is. It is present in Java dot math dot big integer. I hope you're able to see. Java dot math dot big integer. Inside that big integer, okay, inside that Java dot math, there is a class big integer. So I'll import like this, import Java dot math dot big integer. That's it. I have to import. When I import, now the compiler gets to know, okay, there is a class called as big integer, and how to initialize for big integer, how do I declare big integer, everything. Now it rules has come. Till now there was no rules. Till now it didn't know what is a big integer at all. Now it knows what is big integer, so it also knows the rules of big integer. So when I compile now, it will understand one thing. Okay, what it will understand? Now I got to know the rules. Since I know the rules, you can't initialize 1 like this. It is telling. It is telling you can't initialize. Why? Because see, you can tell int a is equals to 5. You can give 5 value to a variable, because here int is not a class. Int is not a class here, right? Int is not a class. That's the reason. But whenever you see something as a class, can you see big integer as a class? Yes. So here 1 should not be given to fact. Why? Because you see right hand side and left hand side, you see that. Okay, what is right hand side? What is this type? This type is integer type. What is this fact variable type? This is a big integer type. Now the question is, can you store a integer type in big integer type? No, operation between two different types is not possible. So integer cannot be stored where? In the big integer. So let me compile and let me show it to you what it is trying to tell, right? What it is telling? It is telling a integer, the number 1 is integer, it cannot be converted to big integer. A 1 cannot be stored in fact of the big integer type. That is what it is telling. Okay, so now the thing is, how do you convert this 1 to big integer is a question, right? How do you convert anything to big integer? That is what we need now. Okay, what we need to convert anything to big integer, right? Now the question is, how do you convert anything to string? Okay, did you see somewhere here? How do you convert anything to string? Yes, can you see here? Yes, string dot value of, right? String dot value of will convert anything to string. String dot value of will convert anything to string. Same thing like that. Okay, big integer dot value of will convert anything to big integer. Okay, I want you to understand that. String dot value of will convert anything to string. Same thing like that. Big integer dot value of will convert anything to what? Big integer. Simple, right? Very simple. So what you want to do now? You are thinking, okay, I got to know 1 cannot be stored in big integer, because integer cannot be stored in big integer. How do I convert this 1 to big integer? By writing this line, big integer dot value of, right? Big integer dot value of. What this will do? It will convert the integer 1 to a big integer. It will convert the integer 1 to what? A big integer. Now can I give this big integer to a fact? Yes, because big integer can be given to big integer. So in that line, now there will be no error. Okay, so maybe if I cut this and if I show to you, if I cut this, okay, so I'll compile, right? And when I execute, so watch here, there is no error now. I am executing, there is no error. Okay, in that line there is no error. Then what is the other line here? Let's see. I'll compile. When I compile, what it is telling? Hey, that line we got, that rule is proper, but this is not possible. bad operand type for the binary operator. Star, is it a binary or unary operator? It's a binary operator because it has two operand. I already discussed this in the class. So that operator has a bad operand, right? Because it can only multiply integers, but it can't multiply big integer. You are telling, don't you think fact is a object now? Fact is a object because it is pointing to a big integer. That big integer is a class, and that class means object here. So you are trying to multiply one object and a number. A operation between two different types is not possible, right? I is of what type? Integer type. Fact is of what type? Big integer type. Operation between two different types is not possible. Okay? Then what you have to do? It is very simple. If you want to multiply, instead of telling star, you have to tell dot multiply. There is a method. Simple. Dot multiply of I. I hope it is clear now, right? Previously, what was there? Previously, there was a star. That star has to be replaced with what? It has to be replaced with dot multiply. Okay, so what you're telling now? You're telling fact is equal to fact dot multiply of I. I hope this is clear now. It is simple, right? What you have done? You have written fact is equal to fact into I. Now you have to write fact is equal to fact dot multiply of I. I hope this is simple. If I compile, okay, now I promise you, this is the last problem. Okay, this is the last problem. After this, we'll definitely get the output. So what it is trying to tell you last time is, it is telling you, hey, multiplication is happening. Okay, I am ready to do multiplication, but I can't multiply fact and integer type. That's what it is trying to tell you. Why are you giving me integer type? Because I, as a multiply method, I can only multiply same type. I can only multiply a big integer and a big integer. Okay, so for multiply to happen, left side should be what type? Big integer type. Is a fact big integer type? Yes. I also should be what type? I also should be big integer type only. Is this I big integer type? No, integer type. So the question is, how do you convert this integer type to big integer type? Can you answer me? How do you convert an integer type to big integer type? Yes, if you want to convert anything to big integer dot value of you have to tell. So big integer dot value of will convert anything to big integer. So if you want to convert I to big integer, you have to use big integer dot value of. Again, let me tell it to you, why? Why? Because multiply method, for this to happen, left side should be what type? Big integer type. Right side should be what type? Big integer type. But is it big integer type? No. How do you convert it to big integer type? By telling big integer dot value of. Okay, this is the way to convert to big integer. Now you think and tell me, for the multiply method, okay, left side, is it big integer type? Yes, fact is of a big integer type. Right side of a multiply method, is it big integer type? Yes, that is also big integer type. So this is the way I'll be getting the answer now. So let me tell now, n value is 4, right? What is 4 factorial? 1 into 2 into 3 into 4 is 24. So if I write, if I compile and execute, definitely compilation no error at all. See, everything is fine. I got the 24 as answer. Now, if I tell n value is maybe 500, definitely we are able to store 5000, any number we are able to store the result. So if I tell 5000, maybe it will take some time to execute, but once it is executed, I got the output. So as you can see, this is a huge number which is as generated. See, definitely this number can't be stored in integer type. Yes. So I hope it is very clear for you, right? That how important big integers are actually for programmers. You can actually keep on creating. The bigger the value you give, the more the time it takes. So definitely it will take more time. So you can try it on your own. So what I would like to do now is, first you can take the screenshot. Take the screenshot of when n is equal to 4. Answer should be 24. Take the screenshot. Okay, don't worry, I'll revise it again now itself, okay, because this is a new concept, right? Yes, let's revise it. So I hope you have taken the screenshot. So let's see here. I'll undo this. Okay. So let me trace what I had done. So initially we had sum is equal to sum plus I. What we have done, we had changed it to sum is equal to sum into I. Then we had understood sum should not start from 0 because multiplication 0 should not be there. Yes, that's why I'm starting from 1. Then we got to know that variable sum should be changing to what? Fact, variable fact. Yes, I have changed it to fact. After that, we got to know what if my n value is 500? Definitely that fact is not able to store the result, because as you can see, multiplication and storing is happening in fact. You are storing the result in which variable? Fact. So the storing the result the bucket, it has to be very big to store the big result. So fact data type has to change. So fact data type has to change. It is not long type, it is big integer type. If you write big integer, since it is a class and it is not present in lang package, you have to import that because it doesn't know what is big integer. When you import that big integer, it is present in math.BigInteger. When you import big integer, that is the time when it gets to know what are the rules of big integer, how to create big integer, what are the methods of big integer. This is the time when it gets to know. So it tells you that a 1 integer type cannot be given to big integer. So convert that 1, okay, convert this 1 to what type? Big integer type, it tells you. So when you convert it to big integer type, big integer value of 1, this is the way to convert anything to big integer, okay. So you have given like that. Then it told, okay, in that line there is no problem, but fact is equal to fact into I. I can't multiply, because star operator is only for integer numbers. Star operator is only for numbers. Your big integer is a class, it is not a number. So if you want to multiply big integer, there is a method called as dot multiply. Okay, so you have to use dot multiply of I. So when you write like this, again there is a problem. Why? Because multiply method, left side should be big integer type, right side should be big integer type. Yeah, left side fact is a big integer. How do you convert this I to big integer? By telling big integer value of I. Okay, value of I. So after this, as our program is done. Our program is done. So this is that big integer program. Okay. Yes. So what I want to explain you is what actually happened here. Okay, what actually happened. So watch here. Okay. See, when you tell big integer, right? Always remember, inside big integer there are many methods. For a class, you have to create an object to use that class. Okay. When you told this line, a big integer fact is equals to, when you told big integer, okay, integer dot value of 1, when you told something like this, immediately one new object is created where the value is 1. I want you to understand, a new object is created because internally big integer value of calls a new keyword. And don't you think when you use new keyword, don't you think one object is formed? Yes. So inside big integer value of, there is a new keyword here. So this new object has an address 1000, right? That 1000 is stored in a fact variable. Okay, that is stored in a fact variable like this. I want you to understand this. Inside this object, what is there? All the inbuilt methods and variables are there inside this big integer, right? So what are the methods of big integer? We'll see that. One of them is multiply, you got to know. So multiply is a method which is present in big integer. Not only that, then what else is there? Then yesterday we had seen, right? Is prime, is probable prime, that is also a method. Then next probable prime, that is also a method. So all of these methods are present in this object. Now I hope you remember, what did I tell? I told fact dot multiply, right? I have told fact dot multiply of I. When I told like this, don't you think what you have done is, inside the fact object there is a multiply method, execute that. This is what you have done actually. Okay, what you have done, when you told fact dot multiply, you have went into the fact object, in that you have executed a method called as multiply, and you are telling I, right? Because that multiply method accepts one parameter and you are passing the parameter. So that's all it is here. Okay, I want you to understand that whenever you tell about big integer, objects, you are talking about objects. Okay, so maybe you can take this screenshot if you want. You can take this screenshot. Okay, so this is what has happened. So what I want to tell you is, okay, whatever I told you, that is big integer value of will convert anything to big integer, that is wrong. Okay, that is wrong. Why? Because it will not convert anything to big integer. Just to get the catch of it, just to get a hold of it, I have made it to by heart like this. Definitely string dot value of will convert anything to string, but big integer dot value of will not convert anything to big integer. For example, I had written 5.5. Can I convert 5.5 to big integer? Right? Let's see. See, not possible. Please don't do this. Okay. What it can do then? Can I write true here? Can it convert boolean to big integer? Let's see. Right? Let's see. Can it convert boolean? No. Okay. Then can it convert string to big integer? I'll write string 2. I'll write string 2. Can it convert string to big integer? Right? It is also no. which means it is very clear it can only convert integer to big integer. What will value of method do? Okay, value of method will not convert anything to big integer. It will convert, okay, big integer value of will convert only, okay, what it will do, it will convert only integer to big integer. I want this to be very clear for you, okay, it will only convert integer to big integer, right? Okay, so that's the way, right? So then, sir, what if I have a string, right? Then what to do? If you have a string, what you have to do is you have to tell new big integer. Okay, you have to create an object manually. When you create object manually by telling a new keyword, okay, so new big integer, in this place you can give 1. I hope this is clear, okay. So if you want to convert a string to the big integer, if you want to convert a string to big integer, you have to use new big integer keyword. You have to use that new big integer keyword. Okay. So let me compile this and execute it. Definitely my fact has to be 1 initially. Sum has to be 0, fact has to be 1. And if I tell 4 factorial, I'll be getting the same output 24. Please take this screenshot also. Take this screenshot. Okay, so I hope you have taken the screenshot. Now after you have taken screenshot here, I'll be telling like this, right? I'll be telling there is a variable a, there is no int variable now, there is a variable a and there is a variable b, there is a variable a and b. So I have created variable a and b. So this variable b, I'll be not creating using new keyword, I'll be using that big integer value of. Okay, only 2 things are there, so it's not difficult to remember. Okay, yes. Here let me give the value 5, here let me give the value 7. Yes. So I'll comment also so that it is very clear for you. So in this new keyword here must, okay, you must pass string only. You must pass string only. Okay, but here you must pass int, okay, int only. I hope this is very clear, right? What will value of do? It will convert only integer to big integer. New big integer keyword, new keyword will convert string to big integer. Okay, these are the 2 ways to create a and b. And if I tell print a and if I tell print b, okay, print a and print b, these are the ways to print a and b. Okay, you can take this screenshot also, right? You can take this screenshot where I'm printing a and b. It is very simple. Okay. Okay. So when you write this line, what had actually happened, right? What had actually happened? Let's see. So when you told big integer a is equal to new big integer of 5, when you told new keyword, so big integer a, don't you think big integer a is a local variable? Since it's a local variable, its memory is in stack. Big integer is equal to new big integer. This is my heap. In the heap, okay, what you are told? You are told a new big integer, means you are told I want a new memory. This new memory has an address, let me realize 1000. That 1000, where are you storing? That 1000 you are storing it where? In the a. You are giving the reference to whom? A, right? So a is pointing to this object. And you are told the value is 5, so the value is 5, you know, that value is stored here 5. And it has all the methods. It has a multiply method, it has other methods which I'll be telling you now. It has is prime method, next prime method, everything it has like this. Then you are told there is, you know, value of method. When you tell value of also, internally new keyword will execute, which means again you will get a new object where 2000 is the address. Again the value is 7 here, and all the same methods are there, you know, all the same methods are there. So this b will contain this 2000 address because b is a local variable, it is present in the stack. This also will point to this object. Okay, it will point to this object. So you created 2 variables, right? Now I'll be telling you, since you understood the memory diagram here, so how to call the other methods, right? Watch here. First of the one of the methods which you have seen is a dot multiply, okay, or let's say next prime number, okay, next probable prime. I'll tell I can use like this, you know, b dot next probable, right? Probable prime. So when I tell next probable prime, for the next prime method you don't have to pass anything. Okay, from the b, what's the next prime number? What's the b value? 7, right? B value is 7. So from the 7, what is the next prime number? The next probable prime is 11. Yes, it is simple. This is one of the method which you have seen in the last class. Then there is something called as E is a probable prime. Sorry, B dot. Okay, B dot instead of next probable prime we have E is a probable prime. For this E is probable prime, there is one condition, right? You have to pass a number which is greater than or equals to 0, some very big number or very small number. Greater than 0 you have to give, not 0, greater than 0. So when I give like this, it will tell me true or false, right? True. Yes, 7 is a prime number. So these are the two methods. And today what we had seen one method, that is multiply. So if you want to multiply, you have to tell a dot multiply of b. This is the way. So what is 5 into 7? 5 into 7, okay, will be 35, right? So we got 35 as the answer. So multiply we had done. Next I want to do addition. If I want to do addition, what is the method name here? The method name is not addition, method name is add. If I tell add, what is 5 plus 7? I will be adding 5 and 7. So 5 plus 7 will be 12, right? It is 12. So we have got the output. Next, let's see here. Then how do I subtract? So what's the spelling for subtract? Is it subtract or subtract? Let's see. Subtract I will tell first, subtract. A dot subtract of b. So a dot subtract of b, if I tell, it will tell there is no method called a subtract. It is subtract, it will tell. Don't tell sub, it's not sub method, it is subtract. Okay. So when I write like this, right, what is a dot subtract of b? It is minus 2. Okay. Why it is minus 2? How it is minus 2? It is very simple. When you tell a dot subtract of b, what will happen is, what's the a value? 5. Subtract minus b value 7. So 5 minus 7 will happen. What is 5 minus 7? Minus 2. Okay. Because wherever there is a subtract, you have to replace that with minus sign. Okay. How to replace with what sign? Minus sign. What is the a value? 5. B value 7. What is 5 minus 7? Minus 2 only. So I hope it is very clear. If you tell a dot subtract of b, you will get minus 2. But if you tell b dot subtract of a, you will get plus 2. So this also method we have seen. Next was a method divide, right? So divide. Let's see here. A dot divide b. Okay. So I have compiled. What is 5 divided by 7? Right? Answer is 0. 5 divided by 7, maybe it is somewhere 0.71, something like that, 0.71. But 0 point, decimal. It is not big float, right? It is not big float here. Okay, it is not big decimal. It is big integer here. Integer. It is still integer only. And in integer, right? In integer, 0 point something means it is 0 only, right? So that's why answer is 0. Okay. So if I execute one more method, that is mod. Okay. Mod b. A dot modulus, right? What is 5 modulus 7? 5 modulus 7. If the numerator is smaller than denominator, answer will be numerator only. Answer is 5. Right? Answer is 5. Right? Yes. What I want you to understand here is, see, all these methods for multiply method, left side is what type? Big integer type. Right side is what type? Big integer. For add method, left side is what type? Big integer. Right side big integer. So for all these methods, left side should be big integer, right side should be big integer. But there is one method here. What's the method? The method is power, right? A dot POW. Okay, this is a different method. I'll comment here by telling it's a different method. It's a different method. Why it is different method? You have to think when you read this. Okay, different method because this is a method which accepts left side should be big integer, but right side should be what type? Integer type, like this. That is 3. This is what I'll tell. If I tell I have to give integer type, what is a dot power of 3? A means 5. What is 5 to the power 3? Right? 5 into 5 into 5. 5 into 5 is 25. 25 into 5 is 125. So 125 will be your answer. Okay. I have taught you mat dot power, but mat dot power will give us what type? Double type, and that double type has a limit. Right? What if you want to find 1 crore to the power 1 crore, right? In that case you have to use this power method. So here if I write any big value, right, it will definitely find me that answer. So this if I write 57 or any other bigger number, it will definitely give me the answer. So if I compile and execute, see, it has given me a very big answer. So this is a power method which I want you to understand. So here let me so these are the important methods of a big integer class. Okay, so I will execute this. I'll have to compile because I've changed something. Whenever I change I have to compile it. Okay, so I'll compile, and when I execute, right, yes, I want you to take this screenshot here. Okay, take this screenshot. Yes, you can take the heading as inbuilt methods of big integer class. Yes. Okay. So these are the methods here. So these are all the methods. Then there is a last method. The method name is compare to. For example, how do you check whether A is greater or B is greater, right? For example, if I write something like this, right, I want to know which is greater. So I'll see if I tell E is 4 less than 5. If I tell E is 4 less than 5, okay, it will tell yes, 4 is less than 5. So the last answer will be true, right? So the last answer will be true. Why? Because 4 is less than 5. But can I use whether A, what is the A value? 5. Is it less than B? Is A less than B here? No, right? A is less than B, but it will not tell me answer, because that less than operator is used for numbers only, right? It is not a number here. So what's the method which I have to use? Okay, that method will be like this. So you have to use A dot, okay, compare to of B. So this is what you have to use here. This is what you have to use. What this will do, I will tell you. What is the A value? 5. Wherever compare to method is there, it will write a minus sign. Wherever compare to method is there, it will write a minus sign. What is the value of B? 7. It will do 5 minus 7. What is 5 minus 7? 5 minus 7, it doesn't care about the answer. It doesn't care. Answer is minus 2. It doesn't care about the answer. What it cares is it a negative value? Is it a 0 value? Is it a positive value? Don't you think 5 minus 7 is a negative value? So the answer will be minus 1. Answer will be minus 1. Okay, you can take some more examples if you want. If you tell 4 minus, if the A value is 4 and if the B value is 100, right? If the A value is 4 and B value is 100, what is 4 minus 100? Minus 96. It will not tell minus 96, it will still tell minus 1 only. So, okay, I hope this is clear, right? It will still tell minus 1. So what is this minus? It will give us a number, it will give us a number back. So if it tells minus 1, what does it mean? It means that the first number is smaller than the second number. That's the meaning of that. Now don't you think here the first number is smaller than second number? Whenever you have first number is smaller than second number, then you will get a negative answer. Okay, so watch here, I'll be explaining in the code. So I have to use dot compare to method. Dot compare to method. So this compare to method, okay, what's the A value? 5. So what is the output of the compare to method? You have to see. Okay, if the output of the compare to method is minus 1, like this, if the output is minus 1, you have to understand that, which means the first number is smaller than the second number. That's the only reason. The first number is smaller than the second number. So if I change the A value, right, if I change the A value to 50 and B value to 7, so if I write 50 and 7, so if I write 50 minus 7, 50 dot compare to 7, 50 minus 7 is plus 43, but it doesn't care what's the value, it just cares whether it's a positive value or a negative value. It's a positive value, so plus 1 will be the answer. Okay, so watch here. So this is the way. So when I compile and execute, compare to method will not give me the difference between the two numbers. It will tell me is it minus 1, 0 or plus 1. As you can see, it's a plus 1 now. It's a plus 1. What's the meaning of plus 1? If the compare to method, if it returns a positive value, it means the first number is greater than the second number. What if both the numbers are equal, right? 50 and 50. Yes. So if it is 50 and 50, what it will do is, it will do 50 minus 50. Was the answer 0? Yes. What is the meaning of 0? Right? If you are getting the compare to method as 0, which means both the numbers are equal, like this. Both the numbers are equal, then only you will get 0 here. You will get 0. Okay, you get 0. Why this 0? This 0 is a mod there. Okay, 50 mod 50 is 0. Okay, subtract this 0, you're getting 50 minus 50 is 0. So I hope you have understood, right? When two big integers are same, the comparative method gives us 0. If a comparative method gives a negative value, it means that first number is smaller than the second number. If a comparative method gives me a plus 1 value, it means that first number is greater than the second number. So this is how your comparative method is. Okay, I'll undo this. Yes. So you can take this point where it will return -1 as the answer, right? You can take this screenshot. Comparative method, you can take this screenshot. So I hope you have taken the screenshot. Okay. Okay. So this was the thing about BigInteger, and I hope today's class was informative. Tomorrow, as the last day of demo class, okay, I'll be teaching you inbuilt methods of integer. Okay, I'll be telling inbuilt methods, which means you don't have to think how do you convert decimal to binary, binary to decimal, decimal to hexadecimal, decimal to octa, octa to hexadecimal. All these kind of things we'll be learning using inbuilt methods. So tomorrow I'll be teaching inbuilt methods, and I'll also teach you how to search for inbuilt methods, right? How do you search, where to go, how to do all of these things. I'll be telling you how to gain knowledge, because if you just go to Google, you can't type, right, inbuilt methods of integer class. If you type, you will get only of integer class. I think most of you came to know yesterday, that there is a class called as BigInteger, right? Yes. So if you know there is a class called BigInteger, you can search in the Google, give me the inbuilt methods of BigInteger class. But if you don't know at all, there is a class called as BigDecimal, how will you search the inbuilt method for that? And now what I will teach you tomorrow is how to get to know what and all classes are there in Java, right? So I'll be telling that. So what I'll be teaching tomorrow is inbuilt methods of integer. Then tomorrow is the last day of demo classes. Then after demo class is completed, you have to join to the course, okay, for which you can text me in the comment section, or you can text me in the WhatsApp where I have given the number. So in the first day of the paid course, we'll be seeing the string. We'll be seeing the string here. String class we'll be seeing. We'll be talking about constant pool, non-constant pool, okay, mutable string, immutable string, that we'll be seeing. Then we'll be starting from scratch, how to reverse a string, what are the ways to reverse a string, in what efficient code we can reverse a string, okay. Then we'll be seeing about time complexity, space complexity, okay. Then in the strings, right, we'll be seeing many other topics like how to remove duplicates from a string. There are many things which I can't be telling because there are so much of things in strings, okay. Remove duplicates, remove ovals, how many ovals are there, and print that character which occurred maximum times. Yes, there is n number of things. So what I'll be teaching you is I'll be teaching everything, because once you learn this, you can solve any kind of questions which they ask, okay. So as you notice, right, when I taught about operators, I thought left and right of operators, up and down of operators, everything I thought, which means any question they ask on operators, you should be able to tell it, okay. Same thing like that in string also. I'll be teaching everything in string, all the methods in string, okay. So there are many inbuilt methods like split and trim, many inbuilt methods are there. So we'll be seeing all of them. We'll be seeing how to use them in programming. Yes, so I hope you all like this class. If you liked it, please definitely give a likes button, okay, give a thumbs up button, and share it to your friends. Thank you for watching.